Hello, myself Bishal De. I am currently second year undergrad of Kuch Bihar Government Engineering College from ECE department. Today, I am going to uh, teach you one of the most important topics in signals and system, the classification of signals. We will break it down step by step, look at the real world examples, and I will also show you graphs for each type so you can visualize exactly what's happening here. Let's get started. So first of all, what is signal? A signal is basically a function that carries information about some physical phenomenon. It could depend on time, space, or both. For example, the voltage output from a microphone changes over time when you speak, and an image changes over two spatial dimension. We classify signals in many ways so that we can understand their properties and decide how to process them. We can classify signals into six main categories like continuous time, discrete time, analog, digital, periodic, aperiodic, even, odd, deterministic, random, energy, and power. Now let's go through each category one by one with examples and graphs. Continuous time signal. Show sine wave graph. A continuous time signal is defined for every value of time. There are no gaps. It's a smooth curve. Example xt equal to sine 2 pi 100t is a sine wave. A real world example is an ECG signal from a heart monitor. Discrete time signal. It shows stem plot graph. A discrete time signal exists only at specific time interval, usually obtained by sampling a continuous signal. Like example, let's take an example. Xn equal to sine 2 pi 0.1 n. Think of a digital window. Your voice is recorded as thousands of samples per second, not as a smooth wave. Now let us talk about digital signal. It show binary signal graph. A digital signal take only discrete amplitude values, usually in binary form 0 and 1. Example, the output from a computer memory. This is make it easier to store and process data without loss due to the noise. Now let us talk about analog signal. Amplitude can take any value in continuous range. An analog system can take any value in a continuous range. Let us take an example like the temperature variation over a day. It changes smoothly without jumps. Analog signals are common in nature like sound, light, and pressure. Now let us talk about periodic signal. Periodic signal, it usually shows us cosine wave graph. A periodic signal repeats itself after a fixed time t. Mathematically, xt equal to xt plus t. Let's take an example. Cos 2 pi t has a period of 1 second. Real world example, the AC voltage in your home. Now let us talk about another category like aperiodic signal. An aperiodic signal does not repeat. Example, a speech waveform. No two sentences have identical patterns. Now let's talk about an event signal. It usually shows a symmetrical parabola graph. An event signal is symmetrical about the vertical axis, meaning xt equal to x negative t. Example, t square. These are important and in Fourier analysis because they only contain cosine terms. Let us talk about odd signal. An odd signal is antisymmetric. Xt equal to negative x minus t. Example is t cube. Odd signal are also important in signal decomposition. They also contain sign terms. The real life application, if we talk about, then it should be harmonic analysis. And now let us talk about deterministic signal.